Howdy gamers! In this video, I'm going to show you how I wrote custom Python code to parse KV files. In my mod, I've ended up writing a lot of Python code to help me generate certain files. Usually this means that I use templates to generate KV files. But more recently, I've had the need to parse the abilities English file so that I can inject the names of abilities into other tooltips and also some documentation I'm working on generating. Now you might ask, why don't I just use a library or some other code that someone's written? The only code that I could find for Python was this GitHub repository. However, it does note that it has a few limitations. One is that it doesn't validate that each starting bracket also has an end bracket. And additionally, it also has issues with strings going over multiple lines. I did think some about trying to extend their code, but there's a few issues that put me off. The first is that it's over 200 lines. And the second is that they seem to be using a lot of regular expressions. Now, regular expressions are good for a lot of things, but not in this case. In this case, there's a much better tool. And that tool is context-free grammars. While this is a gross oversimplification, context-free grammars are basically a more powerful version of regular expressions. They're meant to specify context-free languages, which describe how a certain language is generated. In our case, we're going to specify the way that KV files are generated so that we can parse them. So now back to the Python code. We can see that I'm using the Lark library here, and I've specified a context-free grammar that describes how KV files are made. We're going to go from the top to the bottom to explain all of this. The first is the start symbol, and that's the starting point for our context-free language. We have KV imports, and this star says that we can have any number being 0 or more. You can see that our first example file has 2 imports, and so that's why this is needed. If we don't put this here, but we try to parse files that have imports, we'll get an error because it'll say that there's extra stuff there that shouldn't be there. The second part is what I'm calling a dictionary. It's not really a dictionary, but that's just the first thing that came to mind. Lark doesn't really care what you call these things, because as far as it's concerned, everything is just arbitrary symbols. And in terms of how dictionaries are made, we first have an escaped string. In this file, that corresponds to this right here. For anyone unfamiliar, an escaped string is basically a string that allows for there to be escape values inside of them. An example here is the /double quote in these abilities English file. If we just do a regular string instead, then it might interpret this right here as the end of the string, even though it's not, which will cause a lot of errors. After the string, we specify that there is a string literal here that is the open curly brace. Anything in this grammar that isn't contained by double quotes is interpreted as a symbol, which is why we can just write KV import and dict here, and it doesn't assume that that is the literal DICT. So after this opening curly brace, we say we need to have 0 or more entries, and then we say we need a closing curly brace. These two elements right here are what force the validation that each opening curly brace has a corresponding end curly brace. The next symbol is the KV import. It basically says we need the £sign followed by base, and then at least 1 or more non-new line characters. Now where things get a little tricky is this entry symbol. That's because it can be turned into multiple different values. The different values are separated by this vertical bar. So it can be changed into 2 escaped strings, which corresponds to these values here, where we have a key and then its value, or it can be another dictionary. In this file, we see we have many keys and then values, and then eventually we do have another dictionary. Afterwards, we have the comment, which is 2 slashes followed by any amount of non-new line characters, and then followed by a new line. So we see here, we have the 2 slashes, we have a bunch of characters that aren't a new line, and then the line ends with the new line. It would also work if we just had this, because the any number expression allows for 0 or more. Now you might be wondering, okay, well we've specified this comment, but it's not actually in any other part of the grammar. We say that the start can have KV imports and dictionaries, but nowhere do we say that it can generate comments. And that's because Lark allows us to ignore certain symbols using this ignore command. We ignore extra white space because we don't need it, and we also ignore comments because we don't need the values of those. If you did want to get the values of comments, you wouldn't be able to ignore this, and you would need to put this in your symbol generation stuff, probably just tacked onto the end of everything. So now to run through everything, we have a start, which can be any number of KV imports. So we see 2 right here, followed by a dictionary, which has an escape string, which we see right here, and then open curly brace, and then any number of entries, which we have the entry super mode, and then followed by the ending curly brace, which is all the way down here. And then the process repeats itself here for this. We have a dictionary right here. It has its escape string, and then its opening curly brace, and then a bunch of entries, and then its closing curly brace. And this process keeps repeating. This dictionary, in turn, also contains a bunch of entries where we have entry, 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 and so on and so forth. So that's how we tell Lark how to parse all this. But we do have an issue after this. What Lark returns is its own custom parsed tree format, and what I want is a Python string and a Python dictionary, essentially. So the next part is this transformer. I won't get too much into the details, but basically you define a method for each type of symbol in the grammar you want to parse. In our case, we have the start, which is here, the dict, which corresponds to this, and so on and so forth. They just have the same name, so it's not too hard to figure out. It can be a little weird to write this code, but if you are willing to print stuff out and experiment a bit, it's actually not too bad. And now the last part is the actual method that I use in order to parse the files in my code. First, we load the file contents, which is actually more complicated than just reading the file. Part of what makes reading this file annoying is that it has a 0 width space, and this is not accounted for with the Lark white space preset. So instead, I have to replace it. In Linux, this seems to be character 65279, which I got by calling ord on the first character when I was realizing it was having issues, but when I moved over back to Windows, I was getting this character instead. I'm not really sure why they interpret the first character differently, but this is just how I fix things. After that, we put the file contents through the parse method of our KV parser up here. We apply the transformer to turn it from the KV parse tree special object things into some plain old Python dictionaries and tuples and such. And then we return the value. And that's it. So in summary, the steps are basically just make your context-free grammar. It specifies the context-free language that describes whatever your text file is. Make a transformer to turn the results from the Lark parse tree object data type into whatever you want. And then make a method that strips out some of the weird characters that end up in the source to KV files that you get from the Dota 2 engine. And parse it and basically just return the values. The code for this will be linked in the description of this video. You can also just check out the source tree of my Dota 2 mod, as it will also be linked. Definitely feel free to use it if you end up using Python, and definitely feel free to give context-free languages a try in any other projects where you might need to parse a custom format, but there isn't a parser written for Python or whatever language you pick. There's parsers like this for all sorts of languages. You just need to know to search for something that parses context-free grammars or context-free languages. Thanks for watching, and I'll catch you next time.